Welcome to your new and final unit, Chapter 12, Statistics. Woohoo! What are we dealing with when we're dealing with statistics? Well, first we're going to talk about something called sampling techniques and then misuses in 12.1, but before I elaborate on that, let's just talk about for a second what statistics is. Like I had said at the end of the last unit, statistics and probability are connected. Statistics is the art and science of gathering, ordering, and analyzing data and making generalizations or predictions from that data. You're bombarded by statistics all the time. Sometimes they are accurate results being put at you, other times it's being stretched for truth. It all depends on what the person wants to do with it when they're throwing it at you. The descriptive statistics, that part's pretty innocent. You're gathering, organizing, and analyzing data, but you have to be very careful about how you gather the data so that you can get, good representation of what's going on, and you want to organize and analyze it as accurately as possible. Inferential statistics is where it can get a little sticky. That's where you're making generalizations or predictions from the data you've gathered, organized, and analyzed. And from there, you have to be very careful that your generalization or prediction comes from that data and doesn't reflect a bias or reflect something you want to sway somebody with, or something like that. So you have to be super careful. So in this unit, we're going to talk a little bit about gathering the data, and then a little bit about how to organize it and put it together so you can share it with other people. That's basically what this unit's taken us. It's like week 1 of a statistics class. It's nothing. We're not going to be diving deep into z-scores and all this other stuff. If you want, if you're taking stats, you're going to see a heck of a lot more than what we're doing here. So I'm just getting your big pinky toe wet here. All right. So as mentioned earlier, probability statistics are connected. In probability, you guys have already gone through a whole unit of that. You have problems like you have these 4 different colored marbles in a bag. You reach in and grab one. What's the probability that the marble you grab is green? You know what's in the bag. You know how many, what color, whatever. But then you're making predictions about what you might draw out if you reach in and grab one, or if you grab 2, or however many. Statistics, on the other hand, you have that same marble bag, but with statistics, you don't know what's in the bag. You know there's marbles, but you don't know how many or what colors. You don't know much about them. And you're not going to dump them all out to see what's going on in that bag. Instead, what you're going to do is just reach in and grab a few. You're not going to grab all of them. You're just going to grab a few of them. And whatever comes out, you're going to use those to make generalizations about what's in the bag. And I know in your head, you're probably already thinking about how there could be problems with this. And yes, and that's what some of the things we're going to talk about. Statistics, it doesn't have to be marbles in a bag. It can be people in a town, or it can be the people in a country, or it can be just all kinds of things. Information about the weather or whatever. So you have to be super careful. A statistician has to be super careful and try to be as ethical as possible with this. Okay, so let's get down to the business of collecting the data. Right, when I said that the marble bag in statistics, you don't know what's in it, well, everything that's in the marble bag is considered to be the population. That's the entire group that's being looked at. But with the population, you can't always use the entire population being studied. So what you do is you have to take a sample. Population and sample are 2 terms that are used in statistics. So that handful that you reach in and grab in the bag and pull out, that's your sample of the marbles. And you have to use that sample to make generalizations about the population. But there's very specific ways to do this. Very specific ways to get your sample and very specific ways to make your generalizations. Now, when you're getting your sample, you want to be very careful about how you do it, because you want your sample to be unbiased. You don't want it to lean one way or another unfairly. because you want accurate results. You want your sample to reflect truly what's going on in the population. You know, if your bag has 3 red, 3 black, 3 yellow, and 3 green, and you pull out 3 black, that's not going to be the best representation of what's going on in the bag, because you're going to assume, oh, I pulled out 3 black marbles, there must be all black marbles in there, or mostly black marbles. And it turns out there's not. There's just equal numbers of the 4 colors. So you got to be very careful about taking your sample so that it's unbiased, and so that it's going to, you know, represent the sample or represent the population accurately. So there's lots of different ways to take samples. Reaching in the bag and grabbing a few is just one way. Let's look at a few sampling techniques. These are not all the sampling techniques possible, but let's look at a few. One of them is random sampling. You're probably familiar with random sampling, you know, random drawings, picking things randomly. In a random sample, each item in the population had an equally likely chance to be chosen. Nobody stood out more than another. Anybody could have been chosen. It's just the luck of the draw. An example I like to give, because I love the random number generators they have nowadays online, so I like to give this example. I read a blog used to read a blog that's really big, and the gal who runs it, I won't say who she is or what blog it is, but she used to give away she still does, she gives away some really nice prizes, and will sometimes give away prizes to multiple people. So what she does is she says, all right, I've got this nice DSLR camera to give away today, for example, just making something up. And so tell me in the comments what you had for breakfast this morning. So she'll do something like that. And then for all the people who respond in the comments with what they had for breakfast, that's her population that's interested in this drawing. But she can't award the prizes to everybody in the population. She needs a sampling of that population. And she wants to do it randomly. She wants everybody to have an equally likely chance to be chosen. So she uses something called a random number generator. It's like online, you can go find one, and it just randomly picks a number, and you can tell it, okay, pick a number between 1 and 10,000. And then whatever number it picks, she finds that number comment, and that person who made that comment wins the prize. And if there's more than one she's given away, then she uses the random number generator more than one time and goes through and finds those people and those comment numbers. So she's taking a sample of her comment population to give away prizes to. So that's one example just of random sampling, like how taking something where anybody could be chosen. There's no like real method to the madness. Another example is another type of sampling is systematic sampling. Systematic sampling, every nth item is chosen. Well, an example might be a manufacturing plant where, let's say, manufacturing plant, let's say it's Campbell's soup or something. I probably shouldn't use brands here, but whatever, soups. And you've got, coming down the assembly line, you've got cans of chicken noodle soup. And they need to, for quality control, they need to test and see how good these cans are. Check to see if there's any defects, because they don't want to send out cases and cases of defective soup, because that would be very expensive to try to recall and deal with. So what they might do is have a robot or a person, say, pick every 8th can of soup off the assembly line. It can be whatever number suits you the best. I just used 8th randomly. Let's say they pick every 8th can of soup off the assembly line and test it for defects. So that can, they'll inspect the can to make sure it looks good, and they would probably open the can and taste test the soup and make sure, and then test it, make sure there's nothing wrong with it. And then if nothing's wrong with it, they can feel pretty confident that the cans of soup coming down the line are fine. If they find something wrong with it, then they know, hey, let's stop the assembly line and check further into this. They can't test the entire population, because then that would leave no soup to send out. If they opened every can of soup and tasted it, then there would be no product left to send out and sell. So they might, just pick every nth item to test. So that's one example of for systematic sampling. Cluster sampling. Cluster is also called an area sample because it does deal with like usually geographic areas. You take a area and divide it into regions. Then you can pick a region randomly, and you can either choose all the members of that region or a random sample of members from that region. For example, let's say we have, pollsters want to poll the citizens of Winter Haven on political stances. They can't poll everyone in Winter Haven. It's just not possible. That population, it's just not possible to hit every single one of them. And they may not want to hit children who can't vote anyways, or some people who are like in the hospital, don't want to bother them. So what they'll do is they'll take a sample of people from Winter Haven. So they could divide Winter Haven into geographic regions, such as conveniently northeast, southeast, northwest, and southwest. The streets have that on there already, so that might be an easy way to divide up Winter Haven. And then they can randomly select number of houses from each region to knock on the door and take the poll. Or if they wanted to, they could pick just one region and then randomly sample or try to talk to everybody in that region. I'm not so sure that's a good idea, because sometimes when you divide geographic regions up, you end up with in one area you might have certain socioeconomic status. So you might not feel like that's going to be a good sample. So you have to analyze carefully your situation to make a decision about how to divide things up and how to pick your random ones to go talk to. So I would think in this case it'd probably be better to sample from each of the 4 regions. That way you're going to likely hit a variety of socioeconomic statuses, a variety of genders, race, all that. You want to have a good representation of the people of Winter Haven. So that's an example of cluster sampling. Cluster or area, just remember you're dividing up a geographic area into regions and going from there. Stratified sample, populations divided by characteristics or strata, and then a random sample is chosen from each division, each characteristic or strata. An example, like what if Salo, at Polk State Salo, wants to poll the students on the Lakeland campus about clubs and organizations. They might want to ask students, hey, is there any club or organizations that you'd like to see get started? Well, they can't go ask every student in Lakeland. Don't have the time or energy or really way to do that. You can try, but it's probably more effective to take a sample of the students in Lakeland. But you want to try to get a good sampling. So one possibility might be to divide the students in Lakeland up by their class standing: freshman, sophomore, junior, senior, and then pick students randomly from each of those classes. That's one way to do it. By dividing them up into classes, you're getting a variety of experiences in college, and then by picking randomly from those divisions, you should be able to get a good representation of race, gender, class, etc. So that's one possibility. It's not the only way to do it, but it's one way to do it. Convenient sampling uses data that's easily obtained, such as the first 20 people who get in line. The library I go to, often there's at least one group, sometimes 2 or 3 groups, who have tables set up right there at the door as you're walking in, because they want to get opinions from you. I've actually had one gentleman who stops me and asks if I'd fill out surveys for him, and I usually oblige, and so does my husband. It's harmless for me. There's other groups that have other things they want to do. So really it's a matter of convenience. They're grabbing all the people who walk up during the time period that they're there. So let's say they want to set up their tables when the library opens. Well, then they're going to just talk to like maybe the first 100 people who walk up, or however many people who walk up while they're there at the table. They're not going to catch the people that night after they leave or on other days when they're not there. So it's a matter of convenience, just grabbing whoever's walking up during that time period. And sometimes with this you might say, hey, after 100 people I'm done. Other times you might say, hey, after 3 hours I'm done, or whatever. So that's convenience sampling. So you do have to look at your situation and decide, which method of sampling would work best in this case. So you don't just You don't just close your eyes and point to one. You got to analyze your situation and decide what is my best way to collect my data here so that I can get an unbiased sample that fully represents the population. Now, that's collecting the data. The other topic in this lesson has to do with data being thrown at you. So one of them was collection of data. The other is the receiving of data. When I talk about this section, I always like to say question everything, because we are constantly bombarded with statistics, especially by advertisers, and often they'll have the right numbers, but then they'll word it or twist it in a way to try to convince you of whatever their agenda is, or convince you to buy something or whatever. Be on the lookout for that. Be aware that that's happening. Not just for yourself, but for those around you. Like if you have children, be aware of this. Keep an eye on TV commercials. Keep an eye on billboards. Constantly being bombarded with stuff, and always ask, is there a possibility that any of this data is missing, or that data could be interpreted differently, before you make your own decisions about things. If they throw you a chart or graph to try to make it look more official, look closely at the chart or graph. Look at the scales and see if they are done correctly, if they're counted correctly, if everything adds up. If it's a circle graph, make sure everything adds up correctly. If it's a bar graph, just look at that vertical scale to see how far apart things are being spread, if it looks fair or not. If you want some examples, check out pages 728 to 730 in the current textbook. In the current textbook, that is section 12.1, and it's the misuses of statistics part of that section, because they go through and show you some examples of some graphs and charts and pictures where misuses are definitely occurring. So check those out. And then when you move into the practice problems for this, what they're going to do is they're going to throw you some scenarios, and they're going to say, take this statement and tell what possible misuses or misinterpretations may exist. So let's take a look at some ourselves. I pulled these right from the book. Let's say you have a situation where you observe that there's more empty spaces in the parking lot of Mamma Mia's Italian restaurant than at Shanghai Chinese restaurant. Okay, that's fair. That's just a statement of observation. You looked at Mamma Mia's, there's a heck of a lot of empty spaces there compared to Shanghai Chinese. But be careful about what conclusion you jump to. Make sure you have enough information to draw whatever conclusion it is you're trying to draw. The person who wrote this problem concluded that, oh, well, that means that more people prefer Chinese food than Italian food. Because they're assuming, hey, fewer empty spaces must be more popular. But ask yourself, is that a fair conclusion? What are some things that might be out or left out, or what are some things that might have not been considered? Such as, first thing that pops into my head, how many total spaces are at each restaurant? That can affect how many empty spaces there are. Like if you have an Italian restaurant that has this huge parking lot, and you have a Chinese restaurant that's just a little storefront with a few spaces out front, having more empty spaces doesn't necessarily mean you're less popular. In fact, the Italian restaurant might be busier than the Chinese restaurant at that point in time. Look at how many cars are in each parking lot. Ask yourself questions like that. And if you have to, if you're there observing, make more observations before jumping to conclusions. Observe, listen, pull in as much data as you can before jumping to conclusions. Another thing that you might also want to consider Uh, what what time of day is it? Is the Chinese restaurant even open? Is the Italian restaurant even open? Some restaurants open later. Like the Italian restaurant might only open for dinner. So right now there might be cars in the lot and maybe it's lunchtime and maybe that's just employees. You don't know. Is there another business nearby with overflow of parking? So those are kinds of things you got to kind of observe and look and ask yourself before just looking at the number of empty spaces. Here's another scenario. Healthy snacks, cookies, or fat-free. Doesn't sound very appealing to me, but whatever. They didn't ask my opinion. So somebody looked at this and went, oh, so I can eat as many as I like and will not gain weight. Weight gain involves more than just fat in your food. I like the joke that look at the manatee. All they eat is lettuce all day and they're super fat. For you personal trainers out there, it's just a joke. Weight gain involves more than food's fat content. In fact, one article I read recently was if you want to lose weight, you do have to eat fats. Not eating enough fat can go against weight loss, but it has to be healthy fats. They gave examples like eating avocados. They have healthy fats. So there's more to it than just eliminating fat from your diet. I could eat a ton of those cookies and I could still gain weight because in my case, I am pre-diabetic, have problems with processing certain sugars. So you can be as fat-free as it wants, but it's too full of white flour and sugar, so then I'm gonna gain weight around the middle from it. So other people, when I was younger, I could eat a whole package and not care. So there's a lot of factors that go into this. And that's where advertising will try to catch you. Those cookies, they'll probably be on the TV. They'll probably have some beautiful woman with long flowing hair and white teeth, perfectly manicured hands, and she'll be delicately eating these cookies and smiling at you. And you'll think, oh, just like her, she's eating them and she's skinny and it's okay. It's like, uh-huh. And what did she do afterwards? She go puke it up? I don't know. So, yeah, be careful. Don't let advertising sway you. Next one, let's just do one more. Billy Joel has appeared in concert at Madison Square Garden more than Elton John. Therefore, Billy Joel must be more popular than Elton John. Big thing wrong with that. Concert venue doesn't determine your popularity. Concert venue is not related to popularity. Just because he's appeared more in that particular venue doesn't mean a thing. Now, I know it's Billy Joel and Elton John, so they're both super famous, super popular, but just for kicks and grins, you know, a statement like Billy Joel has appeared in concert at Madison Square Garden more than Elton John. Well, what if Billy Joel has only appeared at Madison Square Garden while Elton John has appeared in like 100 places and actually appeared more? You don't know. They haven't given you enough information here yet about everything going on in those two people's professional lives. You don't know about record sales or nowadays just music sales or whatever. You don't know about other factors, so you can't just draw this conclusion that Billy Joel must be more popular because he appeared in that one place more frequently. So just be on the lookout for that and think about it. All right, so after you practice getting into that mindset, The next lesson, what we're going to do is we're going to start taking data and actually organizing it and figuring out how to display it so that other people, you can share the data with other people and go, oh, okay, this is what I've got, and here's an accurate way of showing what I've got. So we're going to get into that in the next lesson. So take care and see you there.